This clip is my second clip on how to solve quite a difficult topic of quadratic equations. My first clip showed the factorization method, which I think is probably slightly easier. However, it's not always possible to solve quadratics using that method, and in fact you'd probably be there forever if you tried. This method deals with using the formula method of solving quadratic equations. So what is the formula then for this method, which is actually quite complicated, but once you've done it a few times you do start to remember it. You need to remember that for quadratic equations x has two possible solutions, and that's where this plus and minus part comes in. So the formula is minus b plus or minus the square root of b squared minus 4ac all over 2a. But where on earth did these a's, b's and c's come from? Well, a, b and c are called coefficients of our quadratic equation. So if we take an example here, there's our quadratic equation, x squared plus 9.5x minus 5, remembering, equals 0. That's our quadratic equation. From this we can get our coefficients a, b and c. Now each of these coefficients a, b and c are found from these terms, x squared being one of them, 9.5x being another, and minus 5 being another. Now a refers to the number which is multiplied by the x squared. Now in this case it's actually 1x squared. We don't normally write the 1. Do not confuse that with a 0. So a in this case is equal to 1. b is equal to the 9.5. That's the coefficient of x here. So b in this case is equal to 9.5. And c is actually equal to minus 5. Remember, in this case you need to remember the sign. So in this case c is equal to minus 5. I now need to put these into that complicated formula. So I have my coefficients here. Let's see if we can put them into this complicated formula by substituting them in. So x is equal to minus b. Well, b is 9.5, so minus 9.5 plus or minus the square root of b squared, 9.5 squared, minus 4 lots of a, well a is 1 times 1, times c, which is minus 5, all over 2a, and a was 1. Let's see if we can now simplify this. Well, we can use a calculator to work out some bits of this, and hopefully for other bits you won't need a calculator. This is where you need to be careful because silly mistakes will cause it all to go wrong. Let's see what we can do. It's still equal to minus 9.5 plus or minus the square root, and this is where I did use a calculator. 9.5 squared is actually 90.25. Now then, this bit here, minus 4 times 1 times another negative number will actually give me a positive answer of plus 20. And obviously 2 times 1 is still 2. So I've started to simplify it. So making this a little simpler then, well, that is equal to still minus 9.5 plus or minus the square root, and this is actually equal to 110.25, all still over 2. Now the square root of 110.25 is actually 10.5. So I can rewrite this minus 9.5 plus or minus 10.5 all over 2a. And remember, this bit is going to give us our two values of x. Let's consider it as minus first of all. So minus 9.5 minus 10.5 is going to give me minus 20 all over 2. So that's going to give me a value of x, which is equal to minus 10. That's my first value. If I now consider this as positive, the plus part, minus 9.5 plus the 10.5 actually gives me 1. So that would give me 1 over 2, give me a value x is equal to 0.5. And those are my two values of x. So how do I know if I'm right? Well, I could substitute them back into this equation one at a time. I'm just going to do one of them. I'm going to take this value and it should give me 0. Let's see if it works. I can check if my two values are correct by substituting it back into my original equation. I'm just going to do one of them. I'm going to take x is minus 10 and put it into this equation, and it should give me 0. So, putting minus 10 into this, I've got minus 10 squared plus 9.5 times minus 10 minus another 5 should give me 0. Well, minus 10 times minus 10 becomes positive, so that's 100 plus 9.5 times minus 10 is actually minus 95, minus another 5, well, obviously gives me 0. 100 minus 95 minus another 5 gives me 0. So I know that that value is correct. Why not give that one a go yourselves? I hope that helps.